Hello and welcome. How is everybody?
Good, how about yourself?
Thank you. Are there any questions? Anything? Okay. Today's topic is a simple linear regression. I will go through some concepts and techniques by providing an example. And this example everybody is familiar with. So let's go to the data about the example. See, this is my data file. And in this data file, I have a midterm marks, I have a final exam, and I have a total 61 students. By the way, this data is the real data. I just took this data from my another class. That class finished, okay? And I don't have a student information ID, so it is perfectly okay to use this data. So what I'm going to do with this data, I will ask some questions, and then I will do data analysis. After that, I will, based on data analysis result, to answer the questions I asked. Okay. So the question I will ask, is there a linear relationship between final exam and the midterm? Okay. So that is the question I am asking. So to do that, I will do data analysis. So I'm using Excel. I go to data, and then data analysis. After that, you select regression. By the way, you can use SPSS to do this, okay? It asks you to input Y range. Sorry. So input Y range, it is from B1 to B62. That is my Y. And X, you enter from A1 to A62. As you can see, I included the labels, so I check out the labels. So after that, I want the output on the, you have option. You want the output in a new worksheet, or you specify output range. So I'll just specify output range. I will say output is in maybe D, not here. Yes, D1, okay. And then I may want also the residue plot. So then I click OK button. All right, so this is my output result, overwhelming the first time you encountered. Every single number here is important. The final exam will have a lot of questions about this result, okay? So this is, remember I asked the question, is there a linear relationship between final exam and midterm? So let's answer this question by graph, okay? So this is the residue graph. This graph, if you see the residue graph spread all over the place, there is no pattern. That is the good residue plot. That means the linear assumption is met. Means there might be a linear relationship between final exam and the midterm, okay? So to statistically answer the question, is there a relationship between final exam and midterm? You go to see the p-value. See, this is your p-value, hypothesis test, okay? So you may say, okay, based on this p-value, remember p-value is universal. When p-value is smaller than 0.05, there is significant relationship. So now my p-value is 0.002, smaller than 0.05. Although I didn't give you the significant level, it is assumed 0.05, okay, or 0.01 or 0.1, okay. So there is a significant relationship between final exam and midterm. We answered that question, okay, just based on this p-value. Of course, we have other methods based on test statistic, okay, and the critical value. So, and we need to answer lots of other questions. So this data give you a starting point so that when I explain the concept and the techniques, you have something related to. Okay, so let's go back to the very beginning. The first number, we see multiple R. Okay, multiple R. This multiple R, again, the value is from -1 to +1, okay, including 0. When this multiple R equal to 0, there is no correlation between midterm and final exam. By the way, we also call midterm is X, final exam is Y. Another name for X is independent variable. Independent variable, midterm. Final exam is a dependent variable, okay? So this multiple R measures the correlation between X and Y in this situation between midterm and final exam. If this number is positive, that means when you increase X, Y also increase. When this multiple R is negative, that means when you increase X, Y decrease. Okay, so maybe I need my OneNote to explain what I said here. I need a pen, okay. So when you have, you want to explore the relationship between X, Y. X is my midterm, Y is final exam. In this situation, we got multiple R 0.3 means when you increase X, Y also increase. That's why the multiple R greater than 0. Okay. Sometimes you produce negative R. If you produce negative R, by the way, we do not distinguish capital R and small r. We also write down small r, same thing, okay? If you increase X, but Y is decreasing when you increase X, in this situation, multiple R is smaller than 0. Okay, so we understand what is this R. And this R, the absolute value of this R closer to 1, the stronger the relationship. Suppose you get this R 0.8, 0.9, that means you have a stronger relationship. Now I get this R 0.38, we call that is the moderate relationship. If you have R 0.1, 0.2, that is the weak relationship. Okay, so that is the linear correlation coefficient R. The other name is multiple R. Okay, linear correlation coefficient R. Next number is R squared. This R squared is 0.14. It is 0.147. It is the same as 14.7%. Okay. 714, it is the same as 14.7%. And that is R squared. Very important measurement in regression analysis. Okay, this R squared measures how much changes in X how much changes in y are due to the changes in x. In other words, how much changes from x contribute to the changes of y. So in this situation, we are going to say 14.7% of the changes in final exam are due to midterm mark. Okay. Or midterm contribute 14.7% to the final exam mark. Okay, so that is the R square. R square has another name, coefficient of determination. Coefficient of determination. Okay, that is the R square. And the next number is adjusted R square. It is adjusted for sample size and any other factors. Okay, give me 1 second, just grab some towel. So adjusted R square, usually it is smaller than R square. It is adjusted for sample size and any other factors. In next lecture, I will give you the formula for adjusted R square, okay, in multiple linear regression. Today is simple linear regression. Okay, simple means we only have one x. Next lecture, we are going to have x1, x2, x3, multiple x. Okay. This is the standard error. It is a standard error for the model. What we need to do, we want to build a model to simulate the relationship between x and y. And that model has the standard error. We hope the smaller the standard error, the better the model. Okay. Observations means number of samples. Okay. So that I explained some regression statistics. And now let's go to the ANOVA table. And you should familiar with this ANOVA table. When we did ANOVA test to compare 3 or more population means, okay, they have similar structure. Okay, similar structure. So I will explain one by one. It is raining outside. So degree of freedom for regression is 1, means you only have one x, just a midterm. Okay, you do not have a quiz, you do not have lab. So this one is regression, degree of freedom for regression. And degree of freedom for degree of freedom for residue is 59. Okay, it is oh, by the way, this one we call K. So K is the degree of freedom for regression equal to 1. Next one, degree of freedom for residue. It is sample size minus K minus 1. Sample size, remember 61. K is 1 minus 1. That's why you get 59. And the last one, degree of freedom for total. That is just sample size minus 1 is degree of freedom for total. Okay. Over here, you have SS, exactly the same as we did 2 lectures before. SS stands for sum of square. And this SS, I will make notation here. It is sum of square due to regression. So we call SSR, sum of square due to regression. And the next one is a sum of square due to error, SSE. Okay. And the last one is sum of square for total. SSR plus SSE equal to SST. So that is SS, and then MS. MS stands for mean square. Okay, this number is mean square due to regression, MSR. And the next one, mean square due to error, MSE. Okay, and you have MS total. Usually we ignore this number. Okay, so what is the relationship between SSR and MSR? The relationship is mean square for regression equal to sum of square for regression divided by degree of freedom for regression. So K equal to 1 in this case. Okay. And then next one is the relationship. What is the relationship between SSE and MSE? Okay. SSE and MSE, it is mean square due to error equal to sum of square due to error divided by degree of freedom for error. It is n minus k minus 1. In this case, it is 59. Okay, so if you use SSE divided by 59, you get MSE. Okay, so that is the MS. And then this one is very important. Okay, test statistic. Test statistic. No, what do you want? Stay, okay. Sorry, my little doggy. This test statistic F, it is actually, what is test statistic F? F equal to MSR divided by MSE. MSR divided by MSE. That is your test statistic. Okay, and once you have test statistic, you compare test statistic with critical value and make decision. And I already explained this one. This significant F, it is just p-value. Okay, p-value equal to this one. Any questions so far? Again, this table is extremely important. Make sure you understand all the numbers, the relationship among this table I listed here. Okay. So next one is the coefficients. Okay, 38.88 is the y-intercept. We use B0. B0 represent y-intercept. And then you have 0.45, we call slope. B1, okay, is the slope. Remember in high school, when you are asked to write down a straight line, you need intercept, you need slope. So let's write down the relationship between midterm and final exam. Okay. So midterm, final exam is y equal to B0 plus B1x. Okay, B0 is here, 38.88, and B1 is 0.45. Okay, 38, I will omit the decimal. Okay, plus 0.45 x. So that is the relationship between midterm and final exam. And this is the linear regression equation. once you have this equation, you can make prediction. So for example, if you have said, if one student midterm is 65, what is the student final exam? What can you predict for this student final exam? You use this formula. So let's predict a student final exam based on the student midterm test. I will do prediction here, okay? So equal to B0 plus B1x. I said this student midterm is 65. So based on this, oops, because I cannot use the cell reference, I have to delete this B0 because I made the annotation, okay? So now let's do it. Equal to B0 plus B1 multiplied by the student midterm 65. So I predict the student final exam would be 68 based on the midterm 65. Okay. So remember these two numbers will help you to write down an equation, linear regression equation. Okay. Once you have the equation, you can make a prediction. So next, we introduce standard error. This number, we have annotation. We have capital S, then small b1. When you go over the online module or go over the textbook, you see SB1 means standard error for slope. Standard error for slope, this number. Okay, SB1, standard error for slope. And then you have test statistic 3.189. So test statistic, it is just B1 divided by SB1 is the test statistic. So if you use 0.45 divided by 0.142, you should get 3.18. Again, we have a p-value here. Okay, and you also have the confidence interval estimate for the slope, lower bound, upper bound. Okay, any questions? Okay, so in this example, we based on the midterm and final exam, what we can do for those marks, we get an equation, linear regression equation here. We get an equation, okay? And we can also answer questions. Is there a linear relationship between X and Y? We draw conclusion based on p-value method. P-value smaller than alpha. So there is a significant relationship between X and Y. So next, we are going to use standard statistical terminology to maybe illustrate the hypothesis test for the slope, okay? There is actually, when you use the linear regression model, when you use this model, you need to make sure there are assumptions, okay? Assumptions for linear model. Those assumptions are, the first one, it is linear. Means X and Y approximately on the straight line. So how do I know? You can create a scatter plot between midterm and final exam to see if there's a linear relationship. So I highlighted midterm final exam. Then I go insert graph scatter plot, scatter plot, final exam. Do I have other options? Yeah, you go to the scatter plot. Okay. So looks like X represent midterm, this Y represent final exam. Okay, so looks like when you increase there, if I draw a straight, I can, if I click that, and I add chart elements, trend line, linear. See, I can produce all the original dots around this straight line, And I can format series options. So this is the straight line here, okay? If I double click this straight line, I can display the equation. And I can display R squared. See, it is small. If I can make bigger, you can see the equation. The same as we produced from the Excel data analysis. Okay? So that is the first assumption, linear. The second assumption is independent errors. The errors must be independent. Okay? And how do you examine these independent errors? You examine the residue plot. So what is the residue? There is another concept. What is the residue? Okay. Residue. So there's a lot concept here. Residue is a very important concept, okay? The definition of the residue is equal to observed Y minus predicted Y. Okay, observed minus predicted, that is the residue. So now let's calculate the residue. So I'm going to do residue here. Okay, so the residue is observed Y. 89 is the observed Y minus predicted Y. Okay, remember when you do the prediction, you use the function here, this linear regression function to do the prediction. Okay, so observed minus predicted Y equal to intercept plus slope times X. X is 89. So anything inside this bracket is a predicted Y. Okay, so 89 minus predicted Y, the result is the residue. And you do this for each and every student. Oops. Okay, so there are redundancy here. Yes, I don't have that much students, okay? No, you have to copy down observed. I have to modify the formula because this slope will not change for, is fixed. So I have to use absolute cell reference for the slope and for the intercept. So $E $. So I modify the formula. Then I copy down the formula, should be okay. Okay, so those are my residue. The formula is here. I used for the slope and intercept, I use absolute cell reference, means $E, $17, $E, $18. The purpose is I want to fix because the intercept and slope is the same for all the point here. I need to copy down the formula, okay? So that is the residue, observed Y minus predicted Y, that is the residue, okay? And if you see the residue plot, when we did data analysis, this is my residue plot. The residue plot does not have a pattern. That is a good residue plot. That means residue are independent, okay? The errors for residue are independent. That is the second assumption. The third assumption is a normality of error. Means the error terms are normally distributed. Normal terms are normally distributed. Error terms are normally distributed. How do you know error terms are normally distributed? You produce normal probability plot. You don't produce, actually computer will produce for you. If normal probability plot roughly on the straight line, that means normality is met, okay? Last assumption, equal variance. Equal variance. Equal variance. If the data is not time series data, assumption 4 is automatically matched. Our data is not time series data. Time series data means it is over time. For example, the consumption of electricity, January, February, March until November, December. That consumption related to the time, that is the time series, okay? So we don't have that problem, so we don't worry about assumption 4 automatically match. Okay. So those are the assumptions for what? If you want to conduct a linear regression analysis, you want to make sure those 4 assumptions are met. And then you draw a conclusion whether there is a relationship or not. If one of the assumptions is violent, you do not bother to do analysis because there is no, the assumptions does not match. There is no need to do further analysis. Okay. Any questions so far? So next we are going to do hypothesis test. Okay. So we are going to answer the question. The question is there a linear relationship between final exam and midterm? Okay, so that is the question. Is there a linear relationship between final exam and midterm? Final exam is my Y, midterm is my X. To formally answer this question, you need to go through the 5 steps, okay? You can use either p-value method or critical value method. Step 1, you need to say, what is the null hypothesis H0? What is the alternative hypothesis H1? Okay. For the model, for hypothesis, we always targeting population, okay? So we do not use B slope. We use beta represent the slope for population. Do not use B. B is for the sample data, okay? So we say beta 1 equal to 0. that is my H0. Beta 1 equal to 0 means there is no relationship, no linear relationship. An alternative hypothesis means beta 1 not equal to 0. Beta 1 not equal to 0 means there is a linear relationship between x and y. Okay. So that is step 1. Step 2, specify alpha, usually 0.05. If it is not given, you assume 0.05. And step 3, test statistic. Okay. Test statistic, you can use t-test, okay? And this formula for t, there's a formula. Linear correlation coefficient R minus rho, I will explain, okay? And divided by square root of, remember test statistic, it is just a formula. 1 minus R squared divided by n minus 2. Okay. And what is R? R is a multiple R you get here. This is R, 0.38, 0.383, that is R, okay? And the rho is the, for population, okay, linear coefficient for population, usually it is 0. So this formula, it is actually, you drop this R, you can safely say this is the test statistic, okay? R equal to 0.38, N equal to 61. You plug in all the numbers and you should get this test statistic. I will move this graph a little bit. You can verify by yourself, okay? So you get this number is 3.189. And this based on formula. You can also based on the result from data analysis here. See, 3.189 here. This is test statistic. Okay. And then step 4, critical value. Because you use t-test, you need to find critical value for t. Okay, and this you need a calculator. Let me see. Value. So well, I just want to grab my calculator, okay? So I'm going to turn my calculator on. Okay, so for calculator, how do you find critical value for t? You do this. You press F5 distribution, okay? And then F2 t distribution. After that, F3 inverse t. And then area is half alpha. Area half alpha. Alpha is 0.05, so area 0.025. And degree of freedom, in simple linear regression, you use n minus 2 is the degree of freedom. N is 61. 61 minus 2, you get 59. Okay, so degree of freedom 59, and then you press EXE. press EXE, you get critical value. Okay, I'm just, anyone want to share your result? I'm looking, I get 2.0009, okay, just 2, okay, simple. Critical value equal to 2, okay. And then step 5, you draw conclusion. Draw a distribution, T distribution. In this distribution, you label critical value. This is 2. Another value must -2. Critical value decide rejection region. Those are the rejection region. And then label your test statistic. 3.189 must be here. 3.189. Obviously, test statistic is in the rejection region, so you reject H0. You reject H0. Take a look at what is H0. So you reject H0 in favor of H1. Beta 1 not equal to 0 means there is a linear relationship between X and Y. Okay. I should modify this question to between midterm and final exam. Okay, between midterm and final exam. Final exam, usually we say between X and Y. Okay. So that is our test, hypothesis test, use T. You could use p-value method. Where is p-value? It is here, see? P-value 0.002. Based on p-value method, you reject H0. Okay. Some students may ask, why you have 2 p-value here? You have 2 test statistics. You have F test statistic. You have T test statistic. F test statistic is for overall model, overall. T test statistic is for individual X. In this example, individual X is a midterm. Okay, that's why you have 2 different test statistics. One is F, the other is T. So that is the simple linear regression analysis. Okay, the only thing I haven't covered so far is measure of variations. I will copy here. So next topic is measure of variation. So I'm going to draw a graph pen and so remember the original data. Suppose I have a point, okay, represent original data. And then we produced a linear regression equation. We actually call in our textbook, this actually should have the y hat, predicted y, use y hat. Okay, so you have y is original data here, and then you have predicted y. For example, predicted y is a straight line. This is your y hat. Okay. And you can also calculate the average y. So suppose this is the average y bar. From this graph, you see you have 3 different y, 3, okay? One is original y, See, this is 89, 56, 91, 82. Those are Y. Y hat is the result of regression. So maybe I will produce Y hat here. I am going to produce a Y hat. I cannot type in that special symbol. I just use hat, okay? So what is Y? By the way, this final exam, this any data in final exam, that is your Y. What is Y hat? Y hat equal to B0 plus B1 multiplied by X. Because I want this formula is true for all the numbers. So I need to modify the cell reference to absolute cell reference. Put the dollar sign, okay? So this is Y hat. Did you see the difference? What is Y? Y is original data. Y hat, predicted Y. So what is the predicted Y for next student? Copy down the formula. So the why dollar sign? So I missed dollar sign here. Dollar F dollar. So should dollar F dollar 17, dollar F dollar 18, then copy down the formula. And you get a predicted Y for all students. Okay, so Y hat. Y bar is easy. Everybody know Y bar, average Y. I'll put it here. What is Y bar? Y bar is the AVERAGE. Average Y. Average value here. Average. Oh, come on, average. Cannot go further down. Yeah, okay. Where is my, so this is Y bar, average Y, 71. Hope you understand those three different Y. One is original Y, the other is Y hat predicted Y, and then Y bar is the average Y, three different Y. Okay, graphical representation is here, three different Y hat, Y bar. Okay, the measure of variation, I also actually mentioned here, see, SSR, SSE, SST. Okay, what is the graphical representation of those SSR, SSE, SST? Okay, so from here to here, okay, this represents SSE, sum of square due to error. Okay, sum of square due to error. Yeah. Observed Y and predicted Y. And then you have SSR from here to here. That is SSR, sum of square due to regression. Okay, so finally you have SST from here to here, from here to here. That is your SST. As you can see from this diagram, SST equal to SSE plus SSR. Okay. So this is the graphical representation of measure of variation. Okay. The other terminology is the standard error of estimate. Standard. Okay. Standard error of estimate. That we use a simple blah blah blah. Maybe I'll use this one. That is our textbook use capital S then subscript YX. Okay, so it is a sum of square due to error SSE divided by n minus 2 take square root. Okay, take square root. It is actually, remember SSE divided by n minus 2 in this situation, n minus 2, it is actually MSE. So it is the same as square root of MSE. So where is this SYX in this output? It is here. This number standard error 10.25. 10.25 is that SYX. Okay, so if you take this 105, take square root, you get this 10.25. Okay, so those are some terminology in this chapter. So in summary, what we did in this lecture, we did a complete example. Okay, we explored the relationship between X and Y, and we explained some terminology as I listed here, and we went through data analysis. Okay, there is a calculator method to produce linear regression equation. Okay, because final exam you are allowed to use Excel, I would suggest you use Excel to calculate what is B0 here, what is B1. Okay, if you do calculator, I will show you the calculator step. The detailed instructions is in the textbook. Okay, so calculator, you start with the first step. Enter data as list 1 and list 2. You need to enter X is list 1, Y is your list 2. After you enter data, you start with F2 button, calculation. And then you press F6, set. And then you have two variable list. And you select list 1. And then you have this is two variable X. Then you have two variable Y. You select list 2. After that, you press exit or EXE button. Okay, exit or EXE button. And then you press F3, represent regression. And then you press F1, select X. And then you press F1 again, ask you which format. You can select AX plus B or A plus BX, your decision. And then computer will give you output A, B, R, and R square will get from your calculator. You can get this A, B, R square from here. This is your R square. Where is your, this is the intercept. This is the slope. Okay. All right. Any questions?
I have a question in regards to the SPSS project.
Yes.
Do we, when is the due date? Because it wasn't listed on D2O.
It is due the week of 11.
So next week?
Yes, Friday. It is actually, give me one, I'll double check.
Thank you.
You're welcome. Week of 11, it is July 17th. July 17th, okay?
Thank you.
You're welcome. Any other questions? All right. That's all for today. Thank you so much for your participation. Good night, and I'll see you next time.